Hello everyone. Today we're going to talk about adding and subtracting. Whenever you add and subtract radicals, you can only add and subtract radicals that have the same root index or radicand. So you can simply refer to that as like radicals. So again, the radical has to have the same root index and the radicands have to be the same. And once you have a coefficient in front of your radical, you can treat the radical like a variable. Like you can only combine your x's. For instance, 2x plus x plus 3y. This is all that you could turn around and combine to where you would have 3x plus 3y. And the same works with your radicals. Your radicals must be like radicals in order to combine them. So again, treat them like the variable. So an example. So we're going to add or subtract. So we're given the problem. The square root of 50 plus the square root of 8. They have the same root index. There are different radicands. So let's look at rewriting these. In essence, simplifying the square root of 50 and simplifying the square root of 8. Square root of 50 turns into 5 square root of 2, and the square root of 8 turns into 2 square root of 2. Now we can add them together. 5 plus 2 is 7, and we have the square root of 2. So 7 square roots of 2. Another example, we have 7 square root of 12 minus the square root of 75. Root indexes are the same, but my radicands are different. So let's simplify them. The square root of 12 turns into 2 square root of 3. The square root of 75 turns into 5 square roots of 3. 7 times 2 is 14, so 14 square roots of 3 minus 5 square root of 3. 14 minus 5 is 9. 9 square root of 3 is my answer. So pause the video and let's see if we can end up with the same answers for problems 3 and 4. Okay, so we work each one individually and simplifying them. I can see that my root indices are the same. They're all square roots, but my radicands in each one are different. So let's see if we can simplify and turn them into radicals that have the same radicand. Well, the square root of 25 is 5. The square root of 27, that can be broken down to 9 times 3, minus the square root of 18. Well, I can write that as 9 times 2, minus the square root of 16 is 4. So this is 5 minus, I can pull that 9 out, so there's a 3 radical 3 minus, and whatever I pull out I'm going to multiply it by 2. I can pull out a 3, so 3 times 2 is 6, minus 6 radical 2 minus 4. So what I have is 1 minus 3 radical 3 minus 6 radical 2. I cannot simplify these any further than what they are. So this is my final answer. Different radicands under there. I can't combine those terms. You can look at it like that, that being the variable x and that being the variable y. I cannot combine those. Okay, next problem. I have different root indices here. This is a square and this is a cube. I cannot combine them. I can simplify this and pull it down. This becomes, so pull that out, and that's 9 square roots of 2 plus the cube root of 10. But unless that was a perfect cube, I can't do anything with it, and 10 is not a perfect cube. So with that one, all I could do is simplify that term in the expression. 2 more examples. If you would like, pause the video and let's see if we get the same answers. Okay, so for the first one here, I can do nothing with 8. 8 is simply 8. If I need to visually, I can put a 1 there in front of the radical 2 to help me with this portion of it. A negative 1 minus 5 is a negative 6. So 8 minus 6 radical 2. And for this one, Root indices, they're the same, they're all cubes. So what can I turn around and be able to pull out from the cube root of 18? Can I simplify 18 into a number that I can multiply 3 times? So let's just say 2 times 2 times 2, well that's 8. Is there something times 8 that I could get to equal 18? No. So it's as though they're in their simplest form. So again, there's an understood 1 in front of both of those. So 1 plus 1 is 2, minus 4 is a negative 2. So I have a negative 2 cube root of 18. Let me write that better. Negative 2 cube root of 18. And that is your adding and subtracting for your radicals. Again, go back here to make sure that we understand. Only like radicals can be combined, meaning they have the same root index and the same radicand. Simplify to see if you can get the same radicand. You cannot change the root index. And then treat the radical like a variable. And we already know how to do that by combining like terms. Treat that radical like a variable. For instance, we could do nothing with this example, the square root of 12 and the square root of 75. But once I simplified, I ended up with the square root of 3, the square root of 3. Now I can combine those. So critically think and structure your homework, and good luck on adding and subtracting radicals.